Okay, welcome to the tutorial to the put the point on the line Desmos activity. So the one that has the three little dots on it. Here's the tutorial for this activity. Okay, now your screen's gonna look a little bit different from mine, just because I'm on the teacher side of things. Um, anyway, so the first slide. Now this whole tutorial video for this activity, it's going to be a little bit quick because really this is pretty straightforward activity. Now it says on each of the next three screens you'll see two blue points and one black point. Imagine a line is going through the blue points. Your task will be to put the black point on the line. So imagine that I was dragging this blue point to a point where I would see an imaginable dashed line that would go through all the points. Anyways, just kind of move along. It says trust your instincts, and yeah. Okay, so it says challenge one, put the point on the line. So imagine that there was a line through these two blue points, and then you want this to go through the point as well. Obviously, this is not going to go through a straight line. So you want to put it at a point where, as close as possible, you kind of got to tilt your head. Imagine that it's kind of going through that, maybe a little bit higher. Okay, so it said, don't spend too much time, move on. All right, but you still need to kind of do it. Challenge two, put the point on the line. So again, now we're looking kind of at a line that's pointing down. Now this is, see, obviously that's wrong. That's too much. Somewhere in the middle, looks about right there. Moving on. And okay, it says, how can we do this better? So what could we make putting on the line point directly on the line easier? How could you be more accurate? Now, I'm not going to give it away right now, but there is a way, and you should know it. It should be clicking your head like that. Okay, now challenge three. Put the point on the line. Put the black point on the imaginary line through the blue point. So now, what is going to help us put this black point on the imaginary line that goes through these blue points? Now, hopefully it's kind of ringing some bells on what to do, but is that it? I don't know. Is this it? Maybe, but you have to play with it. Anyways, you're trying to put the point on the line as close to possible, and you'll see that right now in challenge one, I had very little error. Kind of got lucky. Now in challenge two, I had kind of a lot of error. More than 0.5 units of error. And then in challenge three, I had absolutely no error. So it was this challenge right here. So why in challenge three did I have no error, or a lot less error than challenge one and two? So respond to that, share with the class. And here's how your class did. It'll show you some stuff, some data on this. This is just mine, so yours will look a lot different than mine. And then explain that data, same kind of idea of what's going on in this screen. Okay. Now, strategy. It's easier to be accurate when there is a grid. That was the clue to the first couple of slides. Was that the grid, the graph helps us. Now there's even another idea of what that kind of helps us as well, and it's kind of getting at that right now. Okay, so this is use the values of A, B, and C below to calculate the value of D. That will put the black point precisely on a line through the blue points. Then watch and check your answer. So right now we have these two blue points. A line is supposed to go through those blue points, and then eventually we're going to change something about the D value. So if we put 6 and submit, obviously that's wrong. So we need that black point to be on this blue line when it comes through those blue points. So we need to edit this. Now, if you go over 1 to the right, A equals 1, and down 2, B equals -2, and then you go from B to C, so this that C line right there, over 4, how much then do you need to go down for D to get way down here, so it'd be on that blue line. Now you need to think about proportionality. So 1 and then -2. And then we went from going horizontal 1 to going horizontal 4. So how much do we have to go down to make up going 4 horizontally instead of 1? Now, it's something to do with 1 over -2 and 4 over, I don't know, is it -9? Nope. You'll kind of have to try it on your own. Hopefully it makes sense when you find the right answer. The fractions of 1 over -2 should equal the fraction of C, our rise over our run. So, or sorry, our run over our rise. Rise over run, rise over run. Anyways. Next one, and you know what? I just reminded myself on the Google Forms, I got this mixed up, so I'll change that right now. It's rise over run, so it's -2 over 1 and 4, or no, sorry, -2 over 1 and whatever D is over 4. So made a mistake. Everybody makes mistakes. Just good when we realize them. All right, now next, is the black point exactly on the line through the 2 blue points? How can you be sure? Use the sketch tools to illustrate your thinking, then press submit. So here are the sketch tools. You can use this, which is a pencil. It's not very good because it won't give you a exactly a straight line. So if you use a pencil, just go back, use this guy right here. It's going to place a dot and then another dot. And you can go from here to there with a straight line, and here to there with a straight line. Now, it doesn't look exactly straight. So what we want to do is use our knowledge of slope to prove that the black point is exactly on the line through the 2 blue points. So, because it is, but we want to prove that. Now, if you go from this blue point to that blue point, you go over 1, 2, and then you go up 1, 2, 3, 4, and you go up about a half. So a half. Now if we go up a half and then 1, 2, 3, 4, so that's 4 half. And you go over 2, 1, 2, we're still on the line, which is good. And then you go up 1 half, 1, 2, 3. Well, it's like I'm right here. So 1, 2, 3, 4, and then a half. Sorry, 4.5, and then over 2. So yes, using slope and the line, we just proved that the black point is exactly on the line through the 2 blue points. So we're reviewing slope. Hopefully that rings a bell. If it doesn't, email me or Mr. Meyer. And then you're going to make a challenge. So that is it for this webcast.